Alright, so here we're going to be talking about angles of a triangle. So it says, what is true about the measures of angle 1 and angle 2? So let's first talk about what we know. So it says lines M and N are parallel. Lines P and R are transversals that intersect at point A. So we know they are equal. Angles 1 and angle 2 are equal because of our rule about alternate interior angles. So because the line P intersects lines M and N, then angle 1 and 2 are alternate interior angles. So they are equal. Then ask, what is true about the measures of angle 3 and angle 4? Well, you actually have the exact same answer. They are equal because, again, they are alternate interior angles. The next question asks, what is the angle formed by angles 1, 5, and 3? So if you look at this, what type of angle is that? And then it says write an equation representing the sum of the measures of the three angles. We know that all three of those angles form a straight line, which we know is 180 degrees. So we can also say that they are all supplementary. So if we figure this out, we know that angle 1 plus angle 5 plus angle 3 are all equal to 180 degrees. So now it says draw a conclusion about the sum of the measures of the angles of triangle A, B, and C, and then explain your reasoning. So because we've said angle 1 and 2 are equal, and because of alternate interior angles, and we've also said that angles 3 and 4 are equal, because of alternate interior angles, we can also say because of our vertical angles, the angle C is equal to everything circled in blue, which would be 3 and 4. And then, of course, angle B is equal to angle 2 and 1, because, again, angle B is a vertical angle with angle 2, and angle 2 is an alternate interior angle to angle 1. So we see that all of those in the same color are the same. And then finally, it needs to know about angle A. So we see that angle 5, that matches up with angle A because it's a vertical angle. So if we look at this and we add up all the green, blue, and pinks, we can see that if we were to add up angle A, B, and C, they again should equal 180 degrees. So what's cool is you can actually do this with any triangle that you get. If you were to extend the lines like this, and when you're drawing a correct triangle, you would find that those angles would be consistent, because we know that all angles in a triangle add up to be 180 degrees, every single one of them. And if you were to continue those line segments, or I guess lines, then you would also see that the vertical angles from those original triangles, then you would also see that they too would add up to be 180 degrees. We'll develop this further as the chapter continues, but this is all good information for us as we continue our study on triangles and their angles. Just for fun, since we have a little bit of extra time, I want to also talk about how to find the angles with a protractor. So one of the first things you need to do is to make sure with your protractor, now mine is not transparent because it's a picture and because of the program I'm using, but yours, you should be able to see through the inside of the protractor, and most importantly, you should be able to see that vertex in the inner part. That's this hole right there. That is what you'll line up with any vertex of the angle. So let's say we are measuring angle C here. The vertex would be this point right there, and you'd be looking at those red lines. So I'm going to take this protractor and do my best to show you how we're going to move it. So actually, I'm not going to measure angle C. I'm going to go over here and try to measure angle 2. So the first thing we need to do, first of all, we know that we need to get the middle point onto the vertex of the angle, but I'm also going to move it around. Remember, you can rotate these. Yours won't increase in size, hopefully, but you can rotate them any way you need to in the book as well. But I'm going to focus on making sure that the baseline or the line that I'm going to use to measure the angle lines up with the 0 on the protractor. So I'm kind of sliding it along the 0 of the protractor. Now again, you cannot see what's under there, but hopefully on yours you can't. So I tried my best to line it up with what I thought would be the vertex. So we can kind of imagine that this is the vertex of that angle. And we have the other line going through here. And you can still see up here the line that was extending from that. And I did a poor job of trying to draw that line there, but you can still see it through there. So we want to count from 0 here. So we see that there's two numbers, 0 and 180. Well, you never want to count backwards from 180. That's difficult anyway. So we want to count from 0 all the way until we reach this blue line up here. So because we see two numbers up here, we need to figure out which of those numbers it is. Okay, so so count with me, I guess. It's 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and finally 120. You see that lines up with that blue line. So we can tell that it should go straight through 120, not 60. This is an obtuse angle, so we should be able to tell that that should go through 120. Now I'm going to move this protractor because it did get a little confusing there since I had that overlapped. So the drawing stayed, and you can see that we've measured the 120 degrees there. So I originally I was thinking I would be measuring angle 2, but I was wrong. I was actually measuring the angle right beside me, which would be the other interior angle on that transversal, which would be the alternate interior angle to, I guess, 5 and 3. So anyhow, you can tell the red line that's pointed there. That would be the angle that we measured. So we said this was 120, which means we should be able to figure out what angle 2 is, given that. So if we knew that was 120, we know angle 2 added together with that should make 180 because it forms a straight line. So what is 180 minus 120? Well, you should know very quickly that that should be 60 degrees. So angle 2 is 60 degrees. That also means that angle B is 60 degrees. This happens to be an equilateral triangle, so all of our angles inside of this triangle will happen to be 60 degrees because they're all equilateral. They're all equal. And that also means that the A, B, and C will be 60 degrees. So that's just an interesting fact. But that's just a quick review on how to use a protractor. Hopefully that made a little bit of sense.